Good morning, everyone. Our chapter today is about powder flowability. Powder flowability is very important in many pharmaceutical aspects, like during compression of tablet, during filling of capsule, the powder should be flowable. Even during mixing of two components together, the powder also should be flowable. Otherwise, it will stick to each other, stick to the equipment, even during sieving or granulation or whatever. Thickness should be less and the flowability should be high. Powder flowability is affected by mainly size and shape of the powder. For example, if the powder is spherical in shape, it will have better flowability rather than being irregular or being having any other shape like cubic or rectangular or whatever. On the other hand, to have a fine powder that's not good for flowability, it's better to have a coarse size. So increasing the size will increase the flowability, and you can understand that if you are comparing the flowability of very fine sugar or crystalline sugar. Crystalline sugar will have higher flowability than the fine sugar, because if you have a fine sugar, any space between the particles will be filled by other fine powder, so the powder will become adhering to each other, very near to each other. There is no air voids in between, and so flowability will be less, more probability of thickness. While in case of granular, especially if it is granular and spherical powder, there will be an air or a space between the powder and the particle and each other. We can improve flowability by adding glidant like talc or starch, and there are so many other examples like stearate salts. We can measure the flowability by many techniques. First one is angle of repose, and the other technique is bulk and tap density. Under bulk and tap density, we have two equations or two ways of measuring flowability. One of them is Hausner ratio, and the other is Carr's index or percentage compressibility. We can start. The first method of measuring flowability is angle of repose. If you have a pile of powder, the angle between the horizontal plane, which is a table or the paper that you keep the powder on, and the surface of the pile, as you see in the picture here, is the angle of repose. It has a symbol theta, and tan theta equal h over r. Of course, h is a distance between the top of the powder and the horizontal plane, which in other words, it is the height of the powder pile, and r is the radius of the powder pile. So using a ruler, you can measure the height, and even you can draw a circle around the powder pile. After removing the powder, you can measure the diameter of this circle and divide by 2, you will get the radius. So again, with more detail, as you did in the lab before, you can fix a funnel at certain distance over a table or over the lab bench. The distance is preferred to be kept as 5 centimeter, and then allow 5 gram powder to flow through the funnel, so the powder will flow and go down and form a pile over the paper. And then the next step is to measure the height of this pile and the diameter of the pile and divide the diameter by 2 to get the radius. Then you can calculate theta, tan theta equal h over r. And this table will show the relation between angle of repose and the flow behavior. You can observe that by reducing angle of repose, flow will become better. But of course, if the powder can slide over each other, if the particle can slide over each other and form a pile with lower height and more diameter or more radius, it means that the powder is more flowable. That is why theta will be less. When h is less and r is more, when you divide h over r, tan theta and theta itself will be less. So reducing theta, it means better flowability. While if you have high theta, it means that you have very poor flowability. No need to memorize this table, even practical or theory. If there is a question, the table will be given, just you can comment based on that. But what you need to remember here is the opposite relation or inverse relation between the value of the angle of repose and the flowability. The higher the angle of repose, the worse the flowability. And we have one example here. If you are pouring 5 gram powder into a funnel, a pile will be formed with a height 3 centimeter and diameter 5 centimeter. So how can you calculate tan theta and theta? H here is given. What is h here? The height is 3 centimeters, so h equal 3. and diameter is 5 centimeter. So don't use 5 centimeter, you have to divide by 2. So the radius will be 5 divided by 2 equal 2.5. So what you have to do is to divide 3, which is the height, over 2.5, which is radius, and then you make like shift 10 for the answer. Then you can get theta, and based on the value of theta, you can comment on flowability. The other technique is using bulk and tap density measurement, and you did that already in the lab. If you add like 5 gram powder or 3 gram powder into a 10 milli cylindrical measure, then you can measure the height or the volume of the powder. This volume is called initial volume because it is measured before tapping. After that, you will do continuous tapping for 5 minutes or 10 minutes, or till you feel that the powder volume is not decreasing anymore. After that, you can measure VT, which is a tapped volume. So now you have two volume, initial volume and tapped volume. From the initial volume, which is V node, you can calculate initial bulk density. Like any density, rho equal W over V. Density equal weight over volume. So for the initial volume, rho node equal weight over V node. For the tapped density, rho T will be equal weight over VT. So from the initial volume, you can calculate the initial density, and from the tapped volume, you can calculate the tapped density. And of course, in both cases, you are using the same weight, which is the weight of the powder that you add or place inside the cylindrical measure. And that is a cylindrical measure. Sometimes we may have automatic shaker, so you can add the powder and program or make the shaker work, so it will shake for a certain time, certain number of minutes. After that, you can record the tapped volume. So here the volume on the left side is the initial volume, and after tapping, the volume may decrease and reach to the lower value, which is VT. From V node, you can calculate again rho node, and from VT, you can calculate rho T. So now what we have V node, VF, and rho node and rho F. You can calculate based on that two values, Hausner ratio and Karl's index. The Hausner ratio can be calculated using this equation. Hausner ratio equal V node over VF. So no need here for rho node and rho F. Once you have V node and VF, you can calculate the Hausner ratio. And again, we have a similar table, and you can observe also again the inverse relation between the Hausner ratio and flowability. If Hausner ratio is very high, flowability is very poor. If Hausner ratio is very small, it means that flowability is excellent. The other value that you can calculate, or the other parameter, is Karl's index or compressibility index. Karl's index equal rho F minus rho node divided by rho F times 100. So here you have to calculate rho F from VF and rho node from V node, and compensate, use this equation to get the Karl's index. And for the third time, we have a separate table for Karl's index with the same concept. The higher the Karl's index, the lower the flowability, or the poorer the flowability. We have an simple example to calculate Karl's index and Hausner ratio. So here, upon pouring 5 gram powder, that is the weight of the powder, so you will use this weight to calculate rho F and rho node. Its volume was 9 milliliters, so that is the initial volume because that is before tapping. So V node equal 9 milli. After tapping for 15 minutes, it means for a long time. We will not use the value of the time here. The volume decreased to be 4 milliliter. So we have V node, which is 9 milliliter, and VF, which is 4 milliliter. If you want to calculate rho node, you have to divide 5 gram, which is the weight, over the initial volume, which is 9 milliliter. If you want to calculate rho F, you have to divide the same weight, which is 5 gram, divided by the final volume, or the tapped volume, which is 4 milliliter. If you have V node and VF, rho node and rho F, you can calculate easily Karl's index and the Hausner ratio. And I didn't tell that, of course, the word tapped, it means final. So VT is the same as VF, and rho T is the same as rho F. Both are tabbed or final, both are same here. So again, we can mention in more detail the factors affecting flowability. First one is particle size, as we mentioned before in the first slide. The smaller the particle size, the worse the flowability. So here, better to have bigger particle size, and that's why we are increasing the size for the first time. Always small particle size is better for solubility, for dissolution, for penetration from the skin, for absorption from the GIT, but here for the first time increasing particle size is better. Granulation is better only for flowability. The second factor is the particle shape. As we mentioned before, the spherical, the shape which is better. So if it is spherical, it will run faster and it will have better flowability. The third factor that we didn't mention in the first slide is hygroscopicity, and we will explain after one or two slides what is hygroscopicity. How to improve flowability? We mentioned also in the first slide that we can add glidant. Glidant like talc, like stearate, or starch. The other way also here, based on the effect of size, the other way is to increase particle size or by granulation. So now let's talk a little about hygroscopicity. We need to know what is hygroscopicity. Hygroscopicity, if the powder is having affinity to take moisture from atmosphere and become stick to each other and less flowable, so we can call it hygroscopic powder. But if the powder has more affinity to take moisture from atmosphere, even beyond the equilibrium, even it will become more wetted, having more humidity or more moisture than the humidity in the weather. So it take more and more water till it dissolve and form a solution. It means deliquescence. Simply, you can tell that deliquescence is a very, very hygroscopic powder. Hygroscopic till certain amount of moisture from atmosphere and become sticky only, but it will remain powder. But deliquescence, it will take much moisture and dissolve in it and form a solution or maybe suspension, but usually it like water and dissolve in it and form a solution. Efflorescent. Efflorescent, that is the opposite of hygroscopic powder. If the powder is efflorescent, it means it has affinity to lose water to the atmosphere. Even if it is hydrate, it may lose water of crystallization or water of the hydrates and become less hydrate or smaller hydrate, or it may become also anhydrous. So again, hygroscopicity, it means has affinity to take moisture from atmosphere till it becomes sticky, while deliquescent take moisture from atmosphere till it dissolve in it, while efflorescent, it means it lose moisture and form lower hydrate or form anhydrous salt. We have several examples of hygroscopic, deliquescent, and efflorescent powder, like ephedrine, hyoscyamine, phenobarbital, pilocarpine. Many drugs are hygroscopic or deliquescent. On the other hand, there are so many drugs also efflorescent, like atropine and cocaine. But the most important thing is that some even excipient, some important excipient like polyethylene glycol and glycogelatin. Glycogelatin used as a base for suppository. Polyethylene glycol also used as a base for suppository. So it means that most of the suppository in the market are hygroscopic. Base of the suppository, it means more than 90% of the composition of the suppository is formed of polyethylene glycol, or more than 90% are glycogelatin. So if the base is hygroscopic, it means the whole suppository is hygroscopic. So how to avoid that? We'll learn also how to protect the suppository from absorbing moisture from atmosphere and being sticky. Before that, we need to know how to determine if the powder is fluorescent or hygroscopic. If we start with 5-gram powder and keep it in very humid weather, and we can take another sample, another 5-gram powder, and keep it in very dry weather, and a third 5-gram powder in moderate humidity, and after a certain time, maybe after 2 weeks, you can just weigh the powder again. Weigh the 5 grams that are kept inside the humid weather, and weigh again the 5-gram powder that kept inside the normal weather or normal atmosphere with intermediate humidity, and also weigh the 5 gram that kept inside dry weather. And just observe the change in weight. If there is a weight gain, it means that the powder take water from atmosphere, its weight become 5.5 instead of 5. It means the powder is hygroscopic or deliquescence. If there is a weight loss, it means that the powder lose water. Of course, if the powder lose water, it will lose water in the dry atmosphere. If the powder gain water, it will gain mainly in the very humid weather. Then we need to know why hygroscopicity is important. Hygroscopicity may affect flowability because if the powder is hygroscopic, it will become sticky and less flowable due to absorption of moisture. And also it will affect chemical stability, especially if our drug is sensitive to moisture, sensitive to water. And we have example of that is aspirin. Aspirin shelf life in presence of water is few days, while away from water, if it is really tablet or dry powder and kept away from moisture, it will remain stable for 1 or 2 or 3 years. So if the drug is ester drug, we have to protect it from moisture. So if it is ester and at the same time hygroscopic, really we need to protect it. So how to avoid hygroscopicity, how to protect the powder or the suppository base from hygroscopicity? We can add some adsorbent, some type of adsorbent like magnesium oxide, magnesium carbonate. So even if the powder, the main powder or the drug powder, trying to capture moisture from atmosphere, the powder, instead of surrounding the drug, it will be hidden inside magnesium oxide or magnesium carbonate, or at least absorbed on the surface of magnesium oxide or magnesium carbonate. So the powder at the end will remain dry, or the mixture will remain dry. Uh, and even during tableting, if you are making tableting, you have to make tableting and put the tablet machine in a room with controlled humidity in a dry atmosphere. And the last step after making tablet or capsule or suppository, packaging is very important. You have to keep it in a blister or foil or bottle where it become totally isolated from the atmosphere or moisture in the atmosphere. Or also you can add a small bag of desiccant. You can see that in some plastic bottles. You can, or glass bottles sometimes. You can add desiccant, something also like adsorbent. Keep it inside the bottle just to protect the powder from the present moisture. Thank you so much and see you inshallah next time.